Hello, everybody. Welcome to the DePIN podcast. I'm your host, Tom Trowbridge. We're excited to bring you interviews with the key founders in the DePIN landscape, investors, and ecosystem partners. This is an exciting time for DePIN, and this year we're going to be meeting even more founders, learning about the projects that they're building, about the traction they're getting, and about the revenue that they're generating. The podcast is brought to you by Fluence. Fluence is building a decentralized compute platform. It's a project I'm a co-founder of and really excited about. So buckle up for this year. Please subscribe to the channel, listen to us on Spotify or Apple. And of course, if you are around any of the large conferences, come to our DePIN Day where you can meet these founders on the Fluence team in person and hear from all the ecosystem partners as well. So look forward to seeing you in person, and let's get going on this podcast. Hello, everybody. Welcome to the DePIN podcast. I'm your host, Tom Trowbridge. I'm thrilled to be here today in our Denver studio around ETH Denver with Ben and Harry, the co-founders of Gensyn. Welcome, Ben and Harry.
Great to be here.
Thrilled to be here. Listen, you guys have been longtime participants in DePIN Day, and so know the story well, but haven't yet had you on the podcast. It's also the first time I've had two co-founders at the same time. So excited about this for all kinds of reasons. For those who are not as familiar with Gensyn, you want to start with a quick summary of what Gensyn is?
So Gensyn is the network for machine intelligence. We connect together any machine learning capable compute hardware in the world. So GPU, CPU, TPU, anything that's capable of doing machine learning operations and allow it to do those operations for anybody else in the world. So we do three main things. We guarantee consistent execution on those devices across heterogeneous compute devices. So if you wanted to execute a machine learning graph for training or inference on a GPU and on a CPU, you could do that and they would be absolutely identical in the execution. So you could hash the execution, you could compare them, they would be completely the same. You also get consistency. So when you do that execution, you can move it over to another device. They're compatible with each other. The second thing we do is communication. So once you've got all those devices doing the same computations, you want them to be able to talk to each other to do computations together. You could split up a large neural network. You could make many different neural networks. You could do anything kind of within the landscape of machine learning execution across these different devices. And then finally, we do verification. So we guarantee trust when the execution happens on an outsourced device without having a human in the loop. So you don't need a legal contract with the owner of the device. You don't need judges and lawyers and things like that if they don't do the work. You can tell entirely programmatically if that work has been done correctly. And then once you've got that entire system, you can settle out transactions for compute. So if somebody has a machine learning model they want to train, instead of them going to AWS or Google Cloud and renting a cluster and training the model there, they can just push it out to this network of nodes. It can train across any number of the nodes in the world. And so the long-term goal of Gensyn is to have every single machine learning operation in the world execute across our protocol on any device in the world at any time.
Those are difficult problems. And that is a big thing to do. And I think what's important for people to understand is there have been GPU providers and GPU marketplaces we've spoken to on this podcast, right? We've had IONET, we've had Akash, a couple of others, right? And so those are marketplaces where people can rent GPUs. That is one level of solution. But what you're talking about, I think, is you've emphasized it, but you mentioned it, but I just want to make it super clear. You're talking about a much more sophisticated solution of actually not just providing a GPU marketplace, but providing the actual verification and the software layer on top of the GPUs that actually provide a service layer, if you will, that adds a lot of value, tremendous amount of value to just the GPU marketplace. Is that accurate?
I think there's two things. Basically, whilst others rent GPUs in the sense that you might be able to say SSH into one of them and start running things, we think about machine learning operations as the good for sale or the unit of the kind of protocol. And throughout history, there's been various units which have been technologically relevant for society. In the 90s, you could think of it like network packets over the internet. In the kind of 2010s or the early 2010s, you could think of it as sort of links in social network graphs. Whoever had the most of those was kind of a dominant economic force. Way back, you think about things like who controlled railroads, aluminium production, steel production, things like that. We think machine learning operations are the critical piece to push the economy forward from here on out and almost present a kind of end of history style situation where we're at a unique point in civilization. If we can scale intelligence to the level that it's bound to achieve in the next sort of 2 to 3 years, it basically puts humans in completely unprecedented territory. We'll have systems which are far smarter than us, can create more economic value than us, can produce cultural artifacts which are maybe not just relevant to us, but also relevant to other machines. But to do that, you need super high scale. And to get scale, you need to maximize the number of available machine learning operations. And to do that, you need a maximum number of devices. And to do that, you have to solve at the most fundamental level the verification, consistent execution, and communication problems that Ben mentioned.
Because to your point, to get that scale, is likely that no one will have enough capacity in one place, right? So you have to then figure out how to stitch together capacity in different locations, different types of machines, different types of devices, effectively, in order to solve whatever that problem is that needs to be solved.
Correct. So from a technical perspective, the three things we focus on concretely look like communication. How do you network together those devices and build machine learning training and inference frameworks which maximally optimize and saturate every device on the network with machine learning operations? So, if you're not doing that effectively, you might be able to peer together lots of devices, but they're relatively, inefficiently used. And that doesn't allow you to get to the kind of scale required. Equally, with consistent execution, when those ops are sent to the devices, we often want to make them bitwise exact reproducible between the devices, because that allows you to compare hashes. And if you can compare hashes of output on devices in an efficient way, then that solves the third verification problem, which allows you to basically guarantee that an untrusted device is actually doing what you ask it to do, and therefore you can fold it into these enormous training runs.
Right. And I just know from the compute that we're doing at Fluence, which is CPU compute, which is not what you guys are doing on the GPU side, verification is a hard thing, because obviously this is all happening. And for people just to say the obvious point, this is off chain, right? This is compute that's happening in GPUs. It's not a smart contract. So you have to figure out the verification problem is more complex.
Yeah, I mean, that's something we've been working on for years. It was the biggest kind of unlock for us. It's the reason we moved into the crypto space. So you can think about the consistent execution and the communication that we've described. You can do that completely without a chain involved. You can connect up devices. You can have them talk to each other. You can have them execute graphs that are very similar. You can have them be compatible, etc. But to actually get that to the maximum scale, as we've said, you have to solve verification. You can solve it in the traditional world, in the centralized world right now, with companies. So I trust a company. I have a contract with that company. They have a lot of compute. I know I can trust all of that compute programmatically because I have this human world trust wrapped around it. I think what a lot of people don't realize is that human world trust is immensely expensive. It's just a hidden cost that we don't think about because it's in absolutely everything. I heard a statistic the other day that the kind of within the entire world's financial system, actually greater than 50% of the transactions happening in that system are pure transaction cost. It's just the cost of having the system exist, essentially. And so you have that same thing within machine learning compute, within any resource. Basically, you need to establish that trust. The beautiful thing about compute itself is that if you can make it deterministic, then you can solve trust programmatically with the consensus of a group of nodes. And that's where we realized that this was a huge unlock when we said we could build this as a company. We could build the compiler, we could build the communication frameworks, we could just KYC every node that comes along, but that would give a ceiling for our growth because the cost of administering every single new node just outweighs the benefit of that node. Whereas if that is just a smart contract execution, that cost goes way, way, way down. But as you identified, the vast majority of what we do, almost everything is off-chain. It's all getting these gnarly computations down to something that a smart contract can actually say, that was correct, or yes, this executed correctly.
The other point, and I want to go back to one thing on trust, but the other point on what you said is that if you were building a centralized company, I think you'd also be responsible for the CapEx of all the GPUs. And doing it the way you're doing it, you have none of the CapEx of the GPUs. So it makes it incredibly capital efficient to end up in a similar place, which is, I think, the beauty of DePIN, which I want to get into. But the one thing I just want to reference on the trust in the financial system. If you go to small towns or almost any place, you look at the banks, right? The banks are the big stone, impressive buildings. And why is that? Because the banks had to inspire trust, had to make it clear that they weren't running away with your money. So how they telegraph that to the average person, they built this massive edifice that just screams permanence, right? And so if you just think about overhead, like there's your physical example of it, like built in stone so that it's clear they're not going anywhere. And you just imagine the cost of that, right? Who are you going to trust, that bank or the guy that is, at a little shop next door, right? You're going to the big one.
Exactly.
Right.
Yep. I think there's a secondary point here, which kind of ties these two things together. That's in 2 to 3 years, when we have machine intelligence that is operating a parallel economy, and maybe the majority of certain industries are their outputs completely machine generated, the economic value is completely driven by machine interactions, those entities and systems won't look to kind of the social proofs that humans look to for verification. They exist in silicon. They don't exist in the kind of, world that we like, the kind of three-dimensional world we live in. So whether or not something's made out of stone, and sits in a small town in America, or whether something's backed by a legal contract, is far less impressive, I would imagine, to a machine than something which is kind of cryptographically signed.
No doubt. And thinking about the trust and the scale, help us understand, there's been a lot of stories about the scale that Elon was able to develop with XAI in kind of record time that surprised kind of Microsoft and everybody else. And obviously OpenAI has a terrific amount of scale as well. So how does that scale kind of compare with what you think is needed, or is the systems that you're going to enable, the compute you're going to enable, allow others to compete with it without that level of CapEx? And if that's the case, then that leads to all kinds of other kind of implications as well.
Yeah. I mean, it definitely enables that. The way we think about it is you can amass that scale in a centralized way. That scale is also applicable if you have a network that can capture it. So if you have a network that can sit across those data centers that these companies are building, as well as all of the latent compute in the world, you can inherit that scale at the same time. The issue with building in a centralized way like this is that's your limit. Once you've built that data center, sure, Elon might be able to get 1 million GPUs in a single data center, but then he's stuck at that 1 million GPUs in a single data center. If you can combine a data center with 1 million GPUs with another one with 1 million GPUs and with every kind of latent device in the world, then you essentially unlock infinite scale. Yes, you've got incentive issues. You've got reasons why companies wouldn't necessarily connect their data centers up, but you've got the kind of centralized company with a very large data center against everybody else. It gives everybody else the opportunity to kind of crowdsource together. And we've seen this in the technical arena so many times with like open source, right? Like there's a large other class against a single company, which can amass much more scale than that company on its own. And so that's what we see with a network like this. The obvious example or the kind of parallel we make is to TCP/IP. So the communication standard of the internet, it allows every single device to communicate over a common framework. We just want to enable the same thing for machine learning computations. So we have that. We all use TCP/IP. We don't even really think about using it, but behind the scenes, it runs all of this communication. The same can be true for machine learning compute. There's lots of people who don't necessarily want that to be the case because their business model relies on it, but it unlocks the greatest scale and the greatest access to this technology because it can be a completely open standard. Previously, building a business against a completely open standard was very difficult. The crypto space gives us the kind of tools to be able to do that as well.
And associated to that thesis is the idea that instead of training in the kind of traditional sense, where if you look at kind of the large transformer models, and then the attempts by, say, Google DeepMind to go into a data center with training frameworks like DiLoco and DePaco, which are essentially downstream from the federated learning research of the mid-2010s, where you are basically doing all reduces between different nodes in a large network, and the smaller you can make the communication, the more efficient the network becomes. We think that there's actually greater opportunity where if you network together lots of heterogeneous devices and you change away from that framework to something which is more, say, reinforcement learning based, you can actually get around some of the communication overheads that these systems end up being bottlenecked by. And we actually made a kind of first kind of public foray into that yesterday by launching RL Swarm, which was our initial kind of, open source contribution to the space. And it allows peer-to-peer training of large reinforcement models without this kind of requirement of all the nodes to sort of essentially
be modelized.
Yeah, exactly.
Listen, the implication of this are such that the barrier to entry right now to have an LM seems to be exactly the point that we mentioned, having your large data center with all these GPUs. And you guys are effectively rendering that, as no pun intended, a no longer a competitive advantage. Right. And so if that goes away as a competitive advantage, that impacts the business model of some pretty big companies at some pretty high valuations. And then to get to these large LLMs, the cost, instead of the capital cost, it becomes the cost of training, which is a fraction of the capital cost. So it effectively, tell me if I'm right, democratizes the ability to build LLMs, which then almost commoditizes LLMs if everyone can build at a much lower price. Is that?
Yeah, I would add one additional point there, which is you still incur a kind of verification cost.
Oh, it's not free.
It's not free,
but
yeah.
it's
a lot lower.
These are the costs.
I mean, an example that say Ben gave, where there's so much of the system is just existing to kind of prop up the system. In this case, the overhead's much smaller and is essentially a function of the opportunity cost of the capital required to be involved in a game theoretic system, where if you cheat, you lose money. The second would be the kind of any adjustments you have to make to the training process to make it deterministic. And then finally, any kind of replication required to kind of spot check various things in the system. That's like partial replication strategies. You take a function of that, that's your verification cost. And our thesis is that that is dramatically lower given our technology than, say, using a traditional system.
There was a bit you mentioned on, just to add on to the commoditization point. We think those large companies building these models are in a tough spot anyway. There was an assumption that building the kind of largest, most effective model would be sort of enough to capture a market. And I think what these companies have been through now is the realization that that is being commoditized. The model layer is entirely commoditized because you can't have a model as a moat. As soon as you give access to a machine learning model through APIs and things like that, it can be distilled by somebody else and they can take the value in that model and they can apply it in their own business. So what those companies realized is we need to find another moat. And as you identified, a very easy moat is the resource itself. Can I just capture most of the resource and stop anybody else from building this thing? And so these companies now are in this race to accumulate the most capital, so they capture the resource, and accumulate the most users, so that they capture that user layer. And in our view, value in this market will accrue to the infrastructure layer and the user layer. So whoever actually has the eyeballs, who has the users in their platform, through personalization, will capture those users long term. So people will get used to the models that they use and they'll stay in these platforms because it's personalized to them. And then on the other end, there will always be compute needed. Every single operation has value. It's expensive to do. It needs to be done. You can't kind of skip performing it. And so that operation has value. And that's why we think at the ops level, instead of thinking at this kind of like hourly cost, etc., we go right the way down to the bottom and say this thing doesn't go away. It continues out into the future. The demand in our view is essentially unlimited. You look at for GPU compute, well, for machine learning compute, you could do that somewhere else. Maybe it goes somewhere else, but
for now,
the machine learning operations themselves just keep increasing because it's such an enabling technology. It can be applied essentially everywhere, and so that demand just keeps increasing.
I'd also add that one of the resources we're trying to maximize are senators, and working to kind of pull up the regulatory drawbridge behind them. Because if you can kind of get all the resources and then maybe even legally prevent other people from amassing them by slipping in kind of carve-outs into legal bills or kind of being, grandfathered in, or even just making kind of legislation or encouraging legislation which has the kind of second order effect of making it impossible to play in these markets.
Yep. Impossible for startups to compete.
Exactly.
The regulatory overhead that would be required to get it.
Yeah.
Listen, that's a whole nother topic, which we could certainly get into. And I frankly think that was getting pretty close in the previous administration to that being executed, from what I understand.
Yeah, it was on knife edge. I think recently there's been a lot of kind of pro crypto and also kind of pro open source movements in the US. You also see the world kind of, I guess, becoming a little bit more hermetic, where you've got kind of American legislation, which tends to be a bit more, at least in the last kind of, few months, pro crypto, pro open source, pro AI. You have the kind of European space with the EU AI Act, which is, in our opinion, relatively draconian. And then China's in an interesting place, up until maybe Q4 last year, it was definitely viewed, I think, quite dimly from a, open source perspective. However, with DeepSeek v3, and the kind of DeepSeek RL work and the recent open sourcing but that company's done as well, it's actually looking a little bit more pro open source. Obviously, how long that persists, unclear. But the world is basically becoming kind of trifurcated into these different regulatory
regimes. Well, it's particularly funny that we have an American living in Europe talking to Europeans living in America. So we have a broad perspective of the different environments. We just need someone American living in Asia or vice versa to complete it.
Exactly.
But let's talk about your guys' backgrounds, because this is not something you just sort of wake up and stumble into. So how did you end up in this sort of deeply technical and enter it into this before OpenAI was a thing, before even, way before Grok, obviously, but you guys were building this and coming up with this before it was obvious to a lot of people. So I'd love to hear the journey there.
Yeah. So I got started in machine learning research in my career, basically. So I did my PhD in deep learning starting a decade ago now in 2015. And I got interested just from an automation angle. So I've been doing computer science. I'd worked as a database administrator. I'd kind of experienced the sort of hands-on development work and administration work, and got more and more interested in what automation could do. Went back to university, realized that actually I could kind of dedicate some time to this. I could research whatever the sort of cutting edge of automation was. And deep learning was kind of burgeoning at that time. It was a few years after AlexNet had been released. And so AlexNet was the first demonstration of a convolutional neural network executing on a GPU. So this was a neural network that had been theoretical for a long time. People had done the kind of mathematical calculations and shown, hey, this should probably work for these tasks. But nobody had really been able to apply it in kind of anger somewhere. And so with AlexNet, somebody applied it on top of a ImageNet large-scale visual recognition challenge, and it blew away absolutely everything that was happening in computer vision at the time. There was an enormous decrease in or increase in the performance on that task from this model, and it took the computer vision world through this sort of really difficult period where you had a lot of professors who'd spent their entire careers working on these kind of manual filters that could be created by humans, and then suddenly this model had appeared that you could run on a GPU that you could just stuff data into and it would be better. And so I joined a department that was sort of going through that process, and I quickly focused on the task of automating the construction of neural networks. So this idea that a human could come in and do the kind of manual construction process of the neural network itself. So instead of manually constructing textures and gradients and things like that, you're actually now building a neural network. Even that doesn't need to be done by a human. You can actually automate that process. And so I focused in on using swarm algorithms to optimize the structure of neural networks. It's a huge parallelizable task where you're training and retraining hundreds of these candidate networks to find the best structure. And out at the end of it, you kind of grow a neural network from scratch. What this exposed me to back then was just the massive compute cost of machine learning, because I took the compute cost of training a model, times it by hundreds, thousands, millions to do this process. And so it became very clear to me that as soon as this got further, even just further in academia, but out of academia, it was going to hit compute constraints, massive compute constraints as it grew. And so that was a kind of huge point.
And when was that, do you think, when you realized that, to the constraints that were going to be inevitable?
That was probably around 2016, 2017.
Gotcha. Before NVIDIA even was. Fair enough.
Yeah. So back then we were just using gaming. We were using gaming GPUs because those were the ones that were available. We would build workstations in our lab and we'd put them under our desks, and they'd basically be a bunch of gaming GPUs stuck together into this like hacked together workstation box that we could use. And then I would network them together to do these searches. But it was all very kind of manual, very hands-on, and like there was no kind of software really at the time. You had like Theano and CAFI as these machine learning frameworks. They've since been kind of replaced with things like PyTorch and TensorFlow. But yeah, it was an interesting time where the vast majority of people were just kind of in research, and then it suddenly took this kind of explosion and took the world by storm.
Yeah, back when NVIDIA was a gaming company.
Yeah, I mean, you could have just bought Leaps on NVIDIA and not worried about any of this stuff. An easier way.
Yeah. I came into it during my postgrad. So I did a combination of basically political analysis and econometrics during my postgrad. And I was in a lab on the university campus doing hunger modeling. And we were using very basic kind of, I guess, like statistical machine learning models for it. But that was where I first got introduced to machine learning. I remember someone came in and gave a presentation about a new variation of random forests. Which is a form of kind of machine learning model that was popular in the kind of, or got more popular in the mid 2010s. And I looked at it and I thought, this is magic. I love it. It's just I'm all in. After my postgrad, I joined a very small scale applied machine learning company and led their data research team. We were basically modeling catastrophe events for reinsurance and insurance companies. So wildfires, floods, hurricanes, also things like building fires, etc. And really, it was a kind of a problem with three dimensions. The first was you had to build data sets which modeled the built environment and kind of, the kind of attendant sort of commercial data of the businesses which were operating in it. Secondly, you had to pair that off against insurable events happening. And thirdly, you had to model it in a way which was, I guess, more performant than the insurance companies themselves. So not like a necessarily easy problem, and one which, we found to be very computationally expensive. And we tried very kind of novel things. So, we had lots of clients in Australia. And I remember one day as a team, we tried to model whether or not, say, UFO sightings were correlated with, wildfire events and things like that. Just really kind of out of distribution things. TLDR, we don't. But the idea was use novel data approaches, use novel machine learning algorithms. At that time, it was basically variations on things like XGBoost and random forest, etc. Insurers were bound from a regulatory perspective to only be able to use GLM models, which meant that we could actually use more kind of advanced ones. But in doing that, we would end up doing these massive grid searches where we were doing hyperparameter tuning, trying out different data sets. And that was because there was a huge class imbalance in the kind of modeling problems we had, where you have, say, a commercial insurance portfolio. It's very rare, but one of them is going to have a catastrophic building fire. It doesn't happen, really. If it does happen, it's like a serious event. And you have against that as the sort of numerator of a denominator of every business in Australia. And modeling, all of those basically meant that we had to be very creative without overfitting the models, how we kind of structured the problem. That was computationally expensive. As that was happening, there was a kind of dramatic increase in the transformer model architecture and the sort of, I guess, like the GPT-2 to GPT-3 happening from OpenAI in the background. I looked at this problem we had with compute, and I looked at the rapidly expanding sort of parameter density of these models, and I thought, this is a bigger problem to solve than the sort of catastrophe prediction. So quit my job in January 2020, right before COVID, which at the time felt, like a mistake, but I met Ben, I think 3 days before the UK lockdown, and we met on an accelerator in London. It's called Entrepreneur First. For those who don't know, it's basically like Shark Tank meets Love Island. If you're familiar with those, where you join as a person who's kind of quit their PhD program or quit their job and wants to start a company, and then you're basically in a kind of pool with lots of other people in the exact same position. You find someone in short order, you try out different ideas, and Ben and I basically connected on sort of three dimensions initially. The first was we both had this shared kind of trauma with machine learning. The second was we both had this sort of fundamentals and around decentralization. I remember like around the time we bonded over things like Edward Snowden's autobiography, around his time at the NSA, etc., and him kind of being an advocate for open sourcing information and basically not having these large centralized entities and systems. At the time, we weren't in crypto, but we had this sort of open source decentralized ethos. Yeah, and the third thing was we just shared a similar sense of humor. And I think that out of every single founding team that we've ever encountered or advised or sort of mentored, even going back to Entrepreneur First occasionally, that's probably like one of the top bits of advice I'd say. Like, if you can't laugh when it's not going well, it's lights out. So yeah, that's how we met.
That's super interesting. I mean, that is first, having co-founders, I'm sure, is a huge benefit. And at Fluence, I have two co-founders, and it's almost like I just feel bad for companies that just have one. And obviously it can lead to complications and whatever, but like the amount of just help you get from a co-founder is terrific. And so I think that is a real benefit that you guys have. And I think it's also, don't hear too often of people successfully meeting and maturing from the accelerator kind of meeting process. And that's a terrific story it's worked out so well that way.
Yeah, it's pretty Darwinian. Like, it's rare that it kind of pulls off. Particularly the super early stages, where you're pre-company. It's not like like some accelerators where you go kind of pre-made.
Yeah, I think for us, we were very clear with each other what we wanted and what we were actually wanting to do, and I think we've kept that through the entirety of Gensyn. Just incredibly straightforward communication, because I think the issues that you get with co-founders or within any kind of business is when you get like breakdowns in communication. So there's kind of misconstrued opinions. There's just miscommunication in the way somebody says something that grows into something bigger, and then you get issues. Whereas if you can just very straightforwardly talk to each other, you could cut through all of that. And so we did that from the very, very beginning. One of the things we do, which we've done for the entirety of Gensyn, is feedback sessions with each other, where we will just give straightforward, direct feedback every week to each other. We'll do it for ourselves, we'll do it for the other person, and it can be about everything that the company has done. But we find that immensely valuable. Can't imagine not doing it at this point, because every week, and what's fascinating is we have notes going back for the entire history of Gensyn, and so you can review those notes and you can see themes that come through. You learn about yourself from somebody else essentially observing you through your entire professional life. It's absolutely fascinating. If you don't do it, I highly encourage everybody to do it with whoever they work closely with, because it's immensely valuable.
It's not light reading.
I have two views on that, because first, at Fluence, my co-founders are pretty direct. And so there is no room for thin skin, and that leads to complete clarity with regard to where everything is. And it's not always pleasant, but it's like, as American, I'm accustomed to, a lot more politeness, I guess I would say sometimes, but it leads to everything being clear, and that is undoubtedly the best. And conversely, previously at Hedera, there was a ton which was not said, happened behind closed doors, this and that, and that led to lots of problems among the management team there at one point. So I think that is a terrific thing. You've got to have the right stomach for it, because not everybody is comfortable getting that level of feedback, and the risk and the potential of taking it personally is high. But if you can handle it, that is undoubtedly a stronger way to go, which is terrific.
100%.
That is that's really interesting to hear, and a great lesson for founders, particularly for co-founders. The DePIN podcast. Back onto the Gensyn protocol and the compute and incentivization. How do you think about that? I know you guys you mentioned you were getting very close to launching. The token will come at some point, but how do you think about incentivization, and how does the DePIN kind of component of this operate?
Yeah, we have a very straightforward view when it comes to incentivization, which is just that this is a market at the end of the day. There's somebody in the world who has a requirement for machine learning operations to be performed, and they're willing to pay for those operations to be performed. There's somebody else in the world who has a resource and wants to rent that resource out, essentially. They want to do operations on the resource and be paid for those operations. So when we think about incentivization, we think about that as the absolute gold standard. That's where you want to get to. That is what drives the entire protocol. I think the crypto space is way overblows incentivization in general. I think there's been a lot of kind of bootstrapping messaging around how you need to kind of create enormous supply, and then that you do that through subsidies, you do that through inflation on tokens, etc., and then you need the demand to catch up. Our view is that actually you want those two things to match, essentially, and if that results in a slower takeoff over the long term, that's probably better for that protocol, because it's actually achieved product market fit, which is almost a dirty word within crypto. You're actually a lot of projects aren't actually thinking about product market fit. They're thinking about something else. They're thinking about pumping a token or something like that. So we think directly at that. That doesn't mean we're completely against incentivization. Every business needs to do that, especially in a marketplace. You've got the cold start problem. You do need to apply certain incentives at certain points in order to get one side to match the other so that you can keep moving. But we view that much more like traditional businesses, where maybe a subsidy should be applied at a certain point in time for a short period of time. But at the end of the day, what you're doing is incentivizing the actual transaction. Another thing we've also seen from a lot of protocols is they'll create this kind of incentive where somebody is incentivized to bring a node and do some kind of computation. But if that computation doesn't resemble the computation your users want to do, you haven't actually built supply for that user base. You've built supply for your kind of proxy incentive. And as soon as you try and switch that over, you're going to have issues. All of the node suppliers are going to freak out. They're going to say, hey, I'm doing this task. Why am I not being paid for this task anymore. I can't do that task over there. And you've incentivized completely the wrong thing. And we've seen so many protocols get captured by their supply side, by their own incentives, where they just can't break out of it. And then eventually you run out of cash, you run out of the ability to inflate your token, and you're done. So to us, it comes all the way back down to that product market fit. Do you have the ability to allow somebody in the world with a resource to do something for somebody else in the world who wants to pay for that resource? And if you do have that, you want to grow that. That's it.
So listen, I violently agree. And I guess I would say that in crypto overall, I think those criticisms are very, very deep and is much more product market fit and revenue focused for sure. But not everybody's done it. And I think the more recent the project, the more likely aligned with what your comment is. At Fluence on our CPU compute, we have a small amount up right now because we pay rewards on that. And so we're only going to grow that as we get revenue. Because the other way to say this is that the days of demonstrating lots of supply and getting value for that are done, right? People care about revenue now and about traction and, to your point, product market fit. But my question was, there's still lots of different ways to do that. So revenue comes in, does it go to you? Does it go to the providers? How do you think about that kind of ecosystem and how that works?
Yeah, so to us, again, it's a pretty straightforward transaction, right? The user comes with a model. They want to pay for the execution of that model. They'll come in the door with a certain amount of tokens. Essentially, they pay in tokens, and they pay those tokens upfront to a smart contract, or essentially a smart contract, and that will pay for everybody involved in the execution of that task. So you've got verifiers, you've got people doing the work, you've got the chain itself, the storage costs, etc. All of that is covered with this initial payment, and then that all settles out through the network. And so the Gensyn protocol just facilitates that transaction. That's it.
And so then, of at scale, the large number of GPUs in the world, do they put themselves up at a certain price, or does the network give them a price? How do they get selected to be a part of whatever operation it is? Because some GPUs maybe rented at one price, others another price. There's geographic proximity. There's the level of the type of GPU. So how do those things get determined?
Yeah, so you need a price discovery mechanism. Obviously, you can have multiple different kinds of price discovery mechanism. So you could have straightforward auction mechanisms across these devices. Obviously, we talk about operations themselves, but operations aren't completely fungible. So you could do operations on an NVIDIA H100, and I could do operations on a MacBook, and those operations are going to kind of look different in the efficiency and things like that. So there's some criteria that we do have to cover, and so we actually explore different price discovery mechanisms. The ideal situation would be to have a straightforward order book over this kind of fungible resource, and then you would have the sort of freest market you could possibly have. In reality, it's actually kind of sharded into more of a kind of complex price discovery mechanism. Another point is you can actually do this outside of the protocol itself, outside of the chain. So our chain does the verification and it does the transaction, but if for whatever reason you found a bunch of compute out in the world and you wanted to use that compute, but you had a trust problem with the owner of that compute, you could facilitate the transaction via the Gensyn protocol. It wouldn't necessarily have to go through the kind of price discovery mechanism of the protocol. The point of the protocol is it handles trust. It handles the kind of execution and the communication for you. But the way that you find the compute, the way you interact with the compute itself is to an extent up to you. The protocol has its job and it does its job.
Yeah. So concretely, things like if we're doing a strategy whereby you have to coordinate lots of geographically disparate devices with high kind of latency between them, you can, model that off chain and then execute on chain within those parameters. So, maybe you're aware of where these devices are and their kind of respective bandwidth levels, the memory of a device, etc. And then given those kind of parameters, you're able to orchestrate what you want. The protocol itself, as Ben said, just focuses essentially on the verification and kind of settlement of the purchase.
Well, it struck me that unlike a lot of DePIN projects, the demand side is more easier to forecast here or to see than the supply side, which is the reverse of most DePINs, because everyone wants to build trained models. You say you could now build your own LLM that's going to cost, without the CapEx. That's interesting to a lot of people, of companies, of protocol, all kinds of stuff, right? So then the question becomes more, instead of that, it's like, okay, how do we secure the amount of GPUs that are available at any point to make it effective or to satisfy that level of demand? And do you have providers lined up? Do you have a plan to get them? Where do you think the GPUs come from?
We've been talking about this for a long time. Obviously, we've been building Gensyn for a good few years now. And in the process of doing that, we've spoken to a lot of people. So a lot of people who are running GPUs, all of the kind of major data centers that we've had conversations with. And early on, we fell into a similar trap to what I think a lot of crypto protocols or like DePIN protocols do in the early stage, which is assuming that you do need to bootstrap supply really heavily at first. And so we did a lot of work to speak to all of these suppliers. What we realized through time was the answer was always the same from them. If this works, obviously we'll do it. If the yield is there, if the yield is consistent, then of course we will run this protocol on our GPUs. Every single GPU we have, which isn't necessarily already rented out to a customer in a long-term contract, we would run on Gensyn because you're leaving money on the table that you don't. And we saw this from the big data centers themselves, where they would mine Ethereum on the side, maybe they'd mine Bitcoin on the side, and they do that because as long as it beat electricity cost, it was beneficial for them to do it. And so this represents an even nicer use case, because instead of mining Ethereum, which is sure, you can do it on the GPU you're going to do for training, but it is a different task and it does stress the GPU in a different way. Our pitch is basically you're just doing the same thing you would have been doing for those customers. And so through time, you get this situation where somebody who does own a data center, sure, in the future, they'll probably have these high value customers. Maybe they give them a white glove service. They sell them a portion of their GPUs for a locked up period of time. They give them support, etc. And that'll be a reasonably high value contract. And then the rest of their GPUs, they're just waiting for finding more of those contracts. So they run Gensyn on those GPUs. What we expect to happen is a realization from those businesses that actually the reduced costs in running Gensyn, instead of having a sales team, customer support team, infrastructure team, all these SLAs and things, will actually make that a more attractive slice. And through time, that'll grow and grow and grow until you have these data center businesses where the vast majority of their demand comes via our network. And the tiny slice is these really high value legacy customers where for whatever reason they pay more because they like the company, they've known them for years, and you've got these relationships. Maybe there's extra services they sell them on top, etc., which is similar to kind of what we've seen in the traditional world, buying IBM, etc. There's reasons why lots of companies buy IBM. The same will be true of data centers. There'll be reasons why some companies pay extra for those data centers. Everybody else will use programmatic protocols in our view.
Two analogies for it are basically, if you think of the data centers looking more and more like Bitcoin miners, where they, at the most extreme setting, if you ever go to any of the the Bitcoin conferences like Mining Disrupt or whatever, and they have the shipping containers full of ASICs and you can walk inside them and they're all humming and everything. That's the kind of most sort of reductive view of it, where these data centers actually just become, they don't even really have as Ben said, a kind of BD function. We're just purely, programmatic and plugged into this network. And actually it starts to look like a service that some of them do offer, which is the kind of ephemeral, spot instance type, service where, is preemptible. So if you can, rent a sort of CPU or maybe even a GPU in some of these hyperscalers, you can run it, but then suddenly, a more preferred customer can kind of come in and turn it off, and then you'll take control of it. In that setting, it's quite similar to mining Bitcoin or Ethereum back when it was proof of work, or indeed being in the Gensyn network, where, you could actually just be taking smaller tasks. And as a consequence, being able to switch capacity to, other activities when required.
Yeah, I mean, listen, it sounds, and we thought about this a lot at Fluence, it sounds like you effectively are a distribution mechanism for a whole bunch of data centers. Anyone with excess GPUs, your distribution, and the more effective that is, and the more distribution you have, the more these providers can rely on you and on nothing else, and the more they don't have to worry about anything else. And that's got to be a real attribute.
Yeah, one of the ways we think about it is it's taking everything that's required to be a data center and making it entirely programmatic and open source, apart from the hardware itself. And so you give the ability to basically anyone who has hardware to become a data center. Even just a user with a laptop can become a data center in their own right, because by using this open source software, they just inherit all of the things they would need to do to be that data center, because it's all handled in code. And then the beautiful part of that is that's far more efficient than handling it in the human world. So we just scale it with electricity rather than scaling it with people, which is far more expensive.
Where do you see then AI and models going? You mentioned earlier, I thought this was interesting, that it becomes more kind of familiarity, user interface based. So you're used to OpenAI because you use it first, or you like Elon, so you're in Grok, and it seems to work fine. Like, does that change? Do we end up in a world with 1,000 different LLMs that all have similar capabilities? Are there political leanings to some that are different than others? Like, how does this landscape evolve in the world that you guys are enabling?
Yeah, so we think about machine learning very low level, right? Like we think about the operations themselves. And when we think like that, we think that technology is going to be applied absolutely everywhere. It's not going to be this concept of everybody using this kind of defined model. It's actually just going to be an enormous parameter space across devices where data is stored in those parameters, and constructing a query or interacting with technology is actually just pathing through that parameter space. And so the idea of these kind of small number of models that exist in the world that we're all using will just disappear. We'll have millions, potentially infinite number of models that all exist at the same time. And all those models will have different biases, the same as humans do. And so our view on the kind of the alignment problem that people talk about, the kind of popular alignment problem within machine learning, is that actually what we're trying to do is just proxy the alignment that exists in the human world, which is we have 8 billion plus humans in the world who all have different biases and we all coexist. We think the future of machine learning is the same.
Yeah.
It's like billions of these models, all with different biases, and then we'll need products that sit on top of that choose the route through the different biases. And like you say, some people prefer different biases. Some people prefer a Western bias to the models they interact with. They only want to interact with models that have those views, and some people prefer other biases. And so I think the users will choose, and then behind the scenes, there'll be this routing through parameter space that just hits the models that make sense for that user. If you as a user don't find any models that reflect your biases, you should be completely free to make your own. And so you can become part of this network of different models. And so we don't like that kind of progression of these singular models controlled by a very small group of people that everybody else is using. But we also don't see that as the kind of long-term future of machine learning. We see a much more kind of modular and composable, just many different pieces of model existing all over the world, a bit like the internet. The internet right now, you make a request, you'll bounce between many devices to get to the website which has the knowledge that you need. And maybe one guy somewhere in the world wrote some text on that website because he knew a lot about that thing. The same thing will be true of machine learning models. It'll just be compressed into parameter space by a machine, not by a person.
Yeah, I'd add one thing to that, which is I think that a lot of the time in the industry, people think of it from a very kind of anthropocentric perspective of like, how does like a human interact with like the model, and then how does they make the model do the thing that they want. The vast majority of economic output in, I guess, the 2030s will be via machine intelligence, and most of it will be machines via other machines. So I think they have the benefit of being able to communicate in a way which is abstracted away from how we communicate. We speak in terms of weights. They can compress everything down to a point where it's unintelligible to a human being. It fails the kind of, explainable AI checks, but is dramatically more efficient and allows those entities to create vastly higher kind of commercial output than humans do. When we want to talk here, we have to kind of frame it all sort of like poetically and speak and everything. For them, it's just ones and zeros.
Right. No, listen, you've heard these two AI agents just recently switch to a different frequency to speak, right? So we've seen that happen at a sort of test level, I would almost say. But the issue I have with Ben's comment is that almost you run the risk there. That's the end of truth. And so that is concerning from a human perspective, because you mentioned the internet. The internet, people more or less trust, you get results through Google. Google ranks them. It's very clear that is a default choice for many people. And yet Google, that's why it's very focused. People pay a lot of attention to where things are in Google ranking, not just individuals, but governments, right? The censor, all this stuff, right? So LLMs, boom, same thing, source of truth, one or two. You've seen what, certain countries are going to ban LLMs, and then there's sort of censorship potential. What questions do you ask? You ask, ones in China about Tiananmen Square, get answers. You ask stuff here about different questions, and Elon, you may not get it right. So, right. So if you're in the world you're talking about, if you can select for what you want to hear, there's no sense of truth. The truth goes away. And that's, maybe the world we're headed to, but that's also scary.
That's the essence of open source, though. It's a leveler. It's the great leveler. It takes away this idea where before, if you wanted to kind of conduct a psyop on a sort of, society, you had to have an army of people who were kind of centrally operating it and controlling the news, controlling the kind of tech companies and media. Now anybody can do it. And the kind of negative there, I guess, the kind of bear case is, well, anyone can do it, which is bad because there's going to be more information. But I actually think that it's dramatically positive, because if the baseline is actually that everything's misinformation, then it makes people much more kind of skeptical. And I think having a skeptical society when it comes to kind of what someone's trying to make you believe is a good thing. I think the period of kind of like post-industrial revolution, dissemination of knowledge through the newspapers and television and, more recently the internet and the social media companies is actually not necessarily the right mode. I think it's too centralized, right? It's obviously wrong, to us at least,
I think it gets a little bit existential, but you think like, what is truth, right? Like, how do we establish truth? And I think like Harry said, in that post-industrial revolution context, we essentially outsourced truth to something that we thought was neutral and trusted, which was like the media and things like that. What we've now realized is actually that's not necessarily trusted. It's governed by a small group of people in a lot of cases.
With a lot of biases.
Exactly. And so we've tried to outsource truth to these trusted institutions. That's not gone particularly well for the world. I think we typically cycle in that way anyway. And so what we think is like, what is actually truth? And truth within the human world, in our view, is actually just consensus, is agreement. So if you trace everything back down, you can come down to things that any individual human would say, that's probably objectively true. At the bottom of all of that is always some kind of agreement between a group of humans. So you look at science, like the peer review process, we agree on whether something is actually correct or not. So we look at that, and we look at that in the human world, and maybe we anthropomorphize it too much, but when we look at the machine world, we say the same thing can exist. And that's what blockchain and crypto is, right? It's consensus over machines. One of the things Harry mentioned earlier, the RL Swarm work that we released yesterday, it works in a similar way to this. So it takes any number of machine learning models, it puts them against a task where they need to define in the task itself, it's actually make a mathematical proof for a certain problem. And so we get many models to do that in a peer-to-peer network. They're all talking to each other. There's no kind of centralized node that they're talking to. And when they do that, they send their answers to each other, and then they critique each other in the way that humans would. And so out of the end of that, what we get is the consensus of the machines. And that's what we decide is truth within that circle of machines. And that can be applied at any kind of size of number of machines, the same way in human society. We apply that within the governance of countries. We apply it within the governance of companies. The way we make decisions as humans typically outsources truth to consensus. And so machines can do that same thing. Crypto gives us the ability to do it. And machine learning models are also able to do it with these systems. As long as they have the ability to establish consensus amongst themselves, then they can make decisions in that way. So as you defined, you could have humans coming in and deciding which models they want to talk to, but over all of those models, you could also have consensus, even though they have different biases. And then theoretically, you get the benefits of diversity, the same as you get benefits of diversity of thinking within the human population as well.
Yeah, I mean, listen, you guys are speaking about, I was thinking about this from a earlier level. You've gone beyond. I was thinking open source, transparent. You can see what's in the model. You can see the code that the model, you can prove the model was trained on what kind of data, right? You can see all that. I thought that would be trusted, but you're going beyond that and saying, sure, that's trusted, but maybe you don't care because, and so maybe they'll have a limitless number of those as well, that each are open source, each are transparent, but have slightly different code, end up in different results. And so you don't end up in the case, then effectively open source doesn't solve that problem. And transparency doesn't even solve that problem. You still end up with lots of different answers.
Yeah. Right? Well, you need all of that, though. Yeah, the open source, you need the transparency. But I guess the step that we take is, instead of a human inspecting that model that they're working with, we say the models inspect each other.
Yeah,
because like Harry said, that kind of the next society is it's governed by machines. As machines doing all of this economic work, we don't have enough humans to check the work of those machines because they scale more effectively than we do. So they have to check each other, and then we outsource the checking.
We think that it's kind of like a tangent, but the verification of training runs is important by itself. So even just right now, you see the kind of skeptics around, DeepSeek's RL release, where it's like, what was it trained on? Like what's in it? Etc. And while a lot of that's overblown, if you read the paper, the numbers, like the 5 million number, which was thrown around, was just basically taken in bad faith, I think, and it was much more. But the idea was we still don't actually know. And there were kind of like, I guess, attempts to try and recreate the training run. There was one on Hugging Face where people were trying to do it. But the idea would be if every model just went through an open source, transparent, verifiable system, then that issue of not being able to even trust like what's in the model goes away. Because there's one thing to sort of like, have a trained model and then skeptically interpret the output. That's fair enough. But if you're the person commissioning the training of the model, you want to know what's being trained on. You want to know what's actually happened. Otherwise you got nothing. Yeah. And you see kind of rumors about this happening. I don't know how like well confirmed it is, but this idea that certain kind of data centers will do kind of like stealth quantization when they're serving models. So, if you really get down to it, if you had a kind of quantized, 4-bit versus 8-bit like llama model, and it's, doing a relatively simple task for you, can you visually, when you read the output, do you know the difference? Maybe it was just, these things are probabilistic. Maybe it was just probabilistically wrong or something, right? And so some of these data centers go, well, you can just kind of, cut the cost,
Yeah. I buy it. Listen, this has been super interesting. We've gone places a typical DePIN discussion wouldn't go, but that is, but terrific, and thrilled about the progress you guys are making. And it's a really important and also scary world that we're headed towards, but you guys are going to enable it, which the most important thing I think is that it democratizes all this stuff in a way that I think is really interesting. So that is fascinating. But there may be some people that are not as excited about that. So we will see. But how do people keep up on what you're doing and stay in touch and follow you guys? What's the best way?
Twitter or X, I guess. X is the best place to find us. Generally keep an eye on our socials. We tweet out everything that we're doing, essentially everything that we release. Our website as well, Gensyn.ai. We've got a lot of roles up there right now. So if people are interested in helping us do this, we are doubling the size of the team this year. We have roles in basically every area of the business. So the main thing we would point people at is Gensyn.ai/careers to come and look at how you can work with us. And if you reach out to us in DMs on socials, we'll generally respond, and we're happy to chat with anyone who's thinking about this. Obviously, we've been thinking about it for a long time. We have a lot of opinions. We love sharing them. We love hearing other people's opinions. So encourage people to message them.
We collaborate with people quite informally on the research side as well. So even if you're kind of at another research house or something and you've heard something which is interesting, we've typically worked kind of just, pretty informally with people before too.
Yeah, we're a startup. We can do lots of different things. Nothing needs to be formal. Some things can be formal. We also have internships, which we recently started doing internships, and we found it immensely valuable. So people who are interested in doing that, it's a shorter term, kind of lighter weight way of interacting with us, basically.
Excellent. Well, plenty of ways to be in touch, and I hope some people look at this and explore and get hired. That'd be terrific. Awesome. Wilson, thanks guys for being on.
Our pleasure.
Very much.
Cheers.
The DePIN Podcast, the place where we explore real-world use cases unlocked by crypto. That's all for today. Thanks for watching to the end. If you enjoyed this episode, please help us grow. Add a like, add a comment, and of course, if you have anyone you think we should be talking to or have on this podcast, either leave a comment there or reach out. But thanks for watching, and we'll see you next week.